Okay, Assalamu alaikum, shabab. Welcome back to the class. As you all know, we have delayed the quiz based on the survey. I think I didn't post the result of the survey, but if anybody has doubts, I can send it. I didn't, honestly. But I think the majority said that they want to make the quiz on Tuesday next week. So I said, okay. That's it. I am again late marking your other quiz. So it seems like I am gonna ruin my weekend and try to finish it up this weekend, inshallah, ya shabab. Unfortunately for me. So inshallah next week, ya shabab, we will announce everything about the end of the course. Okay, I will talk to the coordinator. And then, do you know that our final exam is way far? I think it is on the 26th of, no, 24th of December. That's a lot. I mean, I think it is about a week from the end of the term. Anyway, we sometimes get lucky to have our major final exam in the beginning, sometimes not. Just wait a second. All right, so let's get started with the material. Today, I mean, we actually almost covered everything about today's lecture, which is fatigue of bolted joint under tension. And basically, if you recall in the last class, we said that one of the most important things about bolt is their stress concentration factor. They are full of it. So we told you that there is a tabulated value of Kf, and this is the tabulated value. And basically, there is an information which I put here as a note, but yesterday, I mean, last class, I honestly didn't comment on it, which is the failure of the bolt. Typically, the failure of the bolt is about 15% under the head of the bolt, and 20% at the end of the thread, the end, and 65% at the interface between the thread and the knot face. Now, so you should expect the majority of failure to happen within the knot. And let me tell you, since we talked about this 15%, there is an information I need to tell you about. I was always delaying it, and I thought maybe this is the good time. Why do we put washers? Why? Anybody has an idea, Shabab? I am not claiming that I know the perfect answer. I know some of the answers. I think there are many ways, there are many reasons why do we have water, but anyone would like to comment? Yeah, Ali, you want to say something?
Maybe, maybe to not damage the surface when screwing.
Okay, that's a good one.
ممكن
علي.
النوت دائما حق النوت مو كبير لك الدرجه ان ما ادري كيف اوصف لك، بس انه حق ممكن النوت يكون صغير فالواشر يكون عازل بينه او انه يمسك يعني.
Okay.
Maybe to increase the contact surface area to decrease the stress.
Mm-hmm. Those are good reasons, and but as far as I know, while the other reasons are may not be direct, you know, may not be, you know, make a direct threat to the bolt, not a direct threat. They can help reduce the stress, as you said, or because we don't want to damage the surface of the blades. That's another reason. But if the surface of the blade get damaged, that's not the end of the world. I mean, yes, it is not nice, but again, it is. Just wait a second. Yes, Doctor. I'm in the class now. Can I call you after class? Yeah. No problem. Don't worry. Okay, I'll call. I have a class at 12 to 1, so maybe from 1 to 2. Okay, bye. So, but the one of the most critical reasons why do we have nut, I mean the washer, is this. Now, in general, ya shabab, there are standard ways to cut things in the industry. Sometimes you will see that the joint will be cut like this, 2 plates drilled, and that's it. There might be a situation where for some reason, okay, the machine shop, the factory will do an extra step and chamfer this, right? And there are many ways. Now, there are many practical implications. Why should you do this? But I am going to tell you one which is very, very risky. Okay, you need always to think about. If we zoom in, ya shabab, if we zoom in and look at the bolt, البولت ya shabab عنده head, and then below goes like this. Do you see that? We just spoke about 15% failure, chance of failure in here. عند الرقبة. Do you understand that? So what happened? If you zoom this out, let me now erase my drawing and let's make it really big, okay? Really big. Now let's just assume that this is one big blade. I don't think this is big enough, and this is another one. And then let's say that the bolt is here. هذا الhead, hexagonal head for the bolt. It will go like this and then like this. طبعا I need to perfect the curvature here. It goes like this. Now, do you see what I'm seeing? Do you see what I'm seeing? This part, it's like me taking my Apple Pencil and putting it right there in my neck. That hurt. Do you see that? So one way to, and not only this, there are even chances that in some situation, the machine shop, the manufacturing facility, or whatever, they don't want to do one single step, ya shabab. Adding one single step when you have a plate and then you drill it, okay? يعني the plate like this, and when you drill it, the drill bit goes inside here like this, and then it gets pulled up, retracted up. And when it goes up, there might be a chance that you will have some burr like that. So in reality, there might be a burr like this. Do you remember? They call it deburr in ME-307-Sec-07-LEC. They call it deburring, which means that after you drill, you go and bring a tool that will flush this little tiny sharp material. Now, this little tiny sharp material might be, you know, very tiny, and the bolt, when you screw it, it will crush it. but there might be a chance that this is what's gonna do. It will cut a little bit, little dent in the body of the bolt right there. وخلاص, that's it. You just triggered the fatigue. You put a very nice site there for fatigue crack to initiate and then grow. And then it will grow like that. So basically you are beheading the bolt from its head. Do you get that? So this is the rule of the washers. The washers will come here like this, okay? And usually washers are machined cleanly. You buy them without burr. They are clean and flat and nice. So when you place the washer in between, ya shabab, not only this, the washer, ya shabab, in many ways you will see that in the end they are actually chamfered. So the washers might be like this, even a little bit round, and if not round, they are still good enough to not have any discontinuity or geometrical irregularity, and then the nut, the head can sit closely, nicely on them, on the washer, and this part will be safe from failure. Do you understand that, Shabab? This is very, very important, okay? It becomes even more important whenever this game of hardness is there. Which one is harder? This one or this one? The bolt or the... And you know, the trick behind hardness is very, very simple. الهاردر يا شباب يشمخ السوفتر. انتهينا. That's it. That's the game. That's the game. Whoever is harder will scratch the other one which is softer. That's it. So if my glasses lenses are made from plastic, so anything can scratch them. But if they are made from glass, then there are certain materials here. If I put them and I try to scratch them, they don't scratch them, which is very nice. Rocks, some rocks, which are not very hard. ما قاعد أتكلم عن أحجار بركانية. You can take them and scratch the cup, يا شباب. Water cup, glass, it will not scratch it. So here the same thing. If this red material is harder than that, then it will scratch it. It will penetrate it. The harder is the stronger. So let's go back to our business. So we talked about KF now, we talked about the washer, and then we talked about the fully corrected endurance limit. This is in the last class. Now, what are we going to do? We are going to establish the fatigue analysis, which is, as you will see, very, very straightforward. Actually, now we are going to solve a problem and we will be good. So in general, whatever is in fatigue is the fact that there is a possibility of having a mean load, which is red line in here, and a possibility of a fluctuating load, which is the amplitude. الامplitude يا شباب هو اللي يعمل up and down. المين هو اللي steady. That's why we call it amplitude and steady loading or mean. All right. Now, we all know that the analysis of any cyclic loading can be easily established by عطني الماكسيمم والمينيمم. Just the same question I am being asked for the project. How what does it mean to have a maximum moment and a minimum moment? What does it? It's very simple. Whenever you have the maximum and the minimum, that's it. The amplitude is equal to the absolute value of the maximum minus the minimum over 2. And the mean is equal to the maximum plus the minimum over 2. That's it. So what are we going to do? We want to find the maximum force in the bolt and the minimum force in the bolt. طبعا الآن يا شباب احنا ايش قاعدين نتكلم عن؟ We are talking about the bolt, not the member. The member will be under compression. And if you recall, يعني cyclic compression may have a really infinite life. Do you understand? So it is not of a concern. مشكلتنا مع البولت. البولت is under tension. So what is the minimum force in the bolt? Look carefully. The force on the bolt is equal to C multiplied by P plus Fi. Now, the thing that you need to understand, okay, which is very important, is the following. Is that when we say we want to know what is the minimum force in the bolt, we just put minimum here and minimum there. Why there is no minimum under Fi? Why?
Because the force fluctuates.
I can't hear you يا علي. انت عندك مشكلة في المايك يا علي since the beginning of the term. If you want, you can type it. Anybody else يا شباب?
دكتور ممكن لنا الفورس fluctuating.
What is it fluctuating? طبعا يا شباب this is the same with the maximum load. There is no Fi maximum. There is no Fi minimum. أبي واحد يا شباب practically. انتم كله تقولون ما نحب الثيري والثيري ما لها معنى واحنا لما نطلع نشتغل ما نستخدم المعادلات. أبي واحد يجي الآن practically. Practically tells me what does it mean to have Fi minimum and Fi maximum, because it is the most interesting, funny joke you will ever hear. Just say it. Explain to me how can we have, يعني you tell us the joke. I don't need to tell you the joke. How is it that Fi become maximum and minimum?
Because it's the zero, doctor.
Fi is zero. انت اللي ضحكت يا سعد. والله زين خوش نكته. Okay, another joke يا شباب. Because the force is fluctuating, I don't know if this is an answer يا علي. Well, let's save the time. Okay. معنى انه الاف اي is fluctuating يعني معناها اذا نفترض بدون تحيز، اذا انت عندك سياره يابانيه مثلا شريت تويوتا، تيجي تويوتا وبعد ما تصنع السياره تجيب موظفين مساكين حقين تويوتا وتقول لهم جلسوا على السياره، وهي السياره تمشي كل واحد عنده مفك واكرب وحل اكرب لانه الاف اي يا شباب is the pretension. فيقولون والله هذا العميل يحب الفلكشويتد لود ما يحب الكونستنت لود. فواحد يجلس على الكفر، هذا شلون يدور مسكين الياباني والكفر جالس عليه انا ما ادري. فواحد يجلس على الكفر ويطيب خاطر العميل ويقوم، هو متخرج من جامعه البترول العميل يحب الفلكشويتد لود، يقوم هذا مسكين الموظف مره يكرب ومره يفك، مره يكرب ومره يفك. This is the joke. If you ever thought انه البري-تنشن بري-لود will fluctuate، ترى بقول لك يعني لما يضحكون عليك لا تزعل. That's the meaning. And it is funny. It's funny. ولا تروح تقول لا انا ما بجيب موظفين، انا اعرف اردوينو وبحط جهاز على اردوينو ويفتح في بلوط السياره ويصكهم، ويفتح في بلوط السياره ويصكهم. وش ذا العيشه ذي؟ هذا يصير فيلم في هوليوود، واحد عنده حاله نفسيه مع البلوط. انا اتوقع يعني، ما ادري وش كون. بعد لو يسمعوكم يا شباب جماعه المانجمنت هم اوريدي يضحكون علينا. يعني لو نقول لهم ان احنا عندنا شابتر 8 عن البلوط والبراغي، اوه الله. يقولون اننا ما خلصتوا من البلوط والبراغي، واحنا نقول لهم لا بعد قاعدين ندرسكم شابتر وعندنا بعد مشكله بولت مره نفكه مره نصكه كذا مجانين. So what happened? This is a constant load. It will never be minimum maximum. It cannot fluctuate. So what happened now? Just knowing that the amplitude is equals to F maximum minus F minimum divided by 2, then the stress is basically equals to that load to the amplitude over area. The area is going to be the tensile stress area, and that's why we have AT. Do you understand? Now look, I will substitute these values, okay? Oh, I pointed out to the maximum and minimum in the wrong way. I will put them in, and when I put them in the equation, I will realize, ya shabab, that Fi here, when I put a minus sign, Fi here will be minus, and Fi is cancelled out. No Fi. Why? It makes sense. إذا الامبليتيود يا شباب في Fi معناها معادلتك غلط. How is an amplitude is not changing minimum and maximum? How? Fi should never appear in the amplitude. And yes, it cancelled out. So we ended up with the amplitude, لاحظوا يا شباب, C, which is the joint stiffness, P maximum minus P minimum over 2AT. Now, what should you expect in the next slide? To see sigma minimum, sigma mean, and inside it, Fi. It makes a lot of sense that Fi is a function, is a parameter that should show up in the mean. So what happened over here? We take F maximum plus F minimum. This is the equation of the mean, divided by 2, and then we divide them by AT. And then if we substitute, you will see that this is Fi, and this is Fi, and both of them are added. Do you see that? So, and you have 2AT over there. So Fi plus Fi will be 2 Fi's, and if you divide them by 2AT, you will have Fi over AT. And this is the what? This is the mean resulting from the fluctuation, because when you fluctuate the load around zero mean, it will go away. You have a maximum minimum, but because they are equal in magnitude, they will cancel out. If you fluctuate such that you have a maximum and a minimum and they are not equal in magnitude, you will generate a mean. That mean is represented by this part. Do you understand this, ya shabab? Is it clear? Now, what happened is this. We go to our friends, which are Goodman, Gerber, and the Azmi elliptic. Do you see that? Now, what happened here is that we know that for Goodman, we put the strength amplitude. We call it. Whenever we put S, it means it's a strength. The strength amplitude over the endurance limit, and then the mean strength, and then divided by SUT. Here, the same, we substitute sigma A with SA over SE, and the same with SM. And if you just need to notice that in here, what do we have? We have SM equals the mean stress is equals to SA plus Fi. Now, what happens is that if we substitute these inside Goodman, we will be able, through Goodman, to know what is the strength amplitude. What does this mean? It means that Goodman, based on Goodman, you will know what is the strength? Means the maximum amplitude that you can apply such that the bolt is safe. That's the idea based on Goodman. Same thing here, we get the strength amplitude based on Gerber, and then we get the strength amplitude based on Esme elliptic. Now, what happened, if you look at the equation, you will see sigma I. What is sigma I, ya shabab? It is Fi over AT. Yeah? And then SE from the table, SUT from the table, and that's it. That's it. Here, one note, ya shabab, one note, which is very important, I need to point out. With the elliptical equation says that the curve should start from SE and go to SY, but it is an ellipse like this. So what happened here, we are going to replace SY with SP. Why? احنا قلنا يا شباب اي شيء له علاقه بالyielding of the bolt, we use SP. SP here is like yielding for the bolt. Okay, so that's why we have SP even in there, which is also tabulated. It's the proof strength. If you know grade A or class 4.8 or something, you will know what is SP. Now, in general, and this is a condition, huh? In general, ya shabab, if we focus on the problem that we talked about before, which is a pipe, okay, like this, and the pipe is pressurized, there is a pressure over here, and this is P, then ya akhwan, we will consider that the atmospheric pressure is equals to 0. Everything is pressurized with that pressure. Anything above it, okay, will be a positive, pressure. So what happened? The fluctuation might goes between, let's say, 200 kilopascal and 150 kilopascal. That's possible. This is possible. So this is the maximum and this is the minimum. But there is another possibility. The other possibility, the maximum is 200 and the minimum is 0. Why 0? Because when the pressure here goes to 0, يا شباب, ما في load. P هذا يصير 0. The compression from the atmospheric pressure, we consider it as our reference, our 0. So there is no compression on the bolt. The bolt will be always under tension, or under tension and 0 load. So this is a very interesting condition when P maximum is the load, هو maximum نفسه. And then P minimum is 0. This is a very common condition. You can think about it. احنا نتكلم عن bolted joint and tension. عدل بتلاحظوا يا شباب بأنه these joints will be subjected mostly to tension. There is no such thing as compression unless you talk about submarine, okay, pipe under the water, whatever. So, and this is not the case that we are talking about right here. So what are we going to do? If we do that, then we can go back to the amplitude equation and delete P minimum part. So sigma A equation will become a little tiny one, Cp over 280. And then you go to the mean equation and also you remove sigma P minimum and you keep P maximum and you call it P. And you have the mean equation like that. This is now a very simplified case. And it is very common, very, very common, especially with the pipe pressure thing. Very common. Now, so what is then the factor of safety? Well, what is the factor of safety? What is NF? Well, NF is going to be SA which is the strength amplitude divided by the amplitude that we are applying ourselves. So if, for example, you have a situation where P minimum is 0, you calculate this, and then you go and say, I want to use Goodman. Goodman says that the amplitude is, لاحظوا يا شباب, الامplitude is the strength amplitude. Because it is strength, it is mostly related to what? To properties like SUT and SE and SP. The only parameter which is coming as a load here is the initial, the preload. And I think the reason behind this is because preload is gonna push the load level on the bolt, and it will reduce the gap for you on how much more you can fluctuate. So it is considered that, okay, أنا البولت دائما عندي, يعني يا شباب البولت, whether you load it or you don't load it, it has an SE. Doesn't matter. And the ultimate strength of the bolt is SUT, whether you load it or you don't load it. And if you think about it, before you turn on the engine, sigma I is there. أنا ما قاعد أتصور إن إحنا يعني فينا شيء في عقلنا قاعدين جايبين بوكس في وسطه بلوط براقي ونقول يلا طلع الفتيك لايف. What is this? No, we're talking about fatigue life for a bolted joint, a joint which is in surface. So in the surface, sigma I is always there, whether you switch on the pressure or not. So it is part of the initial condition deal, and that's why it appears in the strength. So in general, if we go to Goodman equation and substitute sigma A and substitute SA, we will find common factors, and we will end up with one single relation. NF equals to twice as SA multiplied by SUT by AT minus FI divided by CP SUT plus SA. You see that? Now, you can do the same, but the other equations are a little bit big. So you better calculate SA and then divide it by sigma A. But because Goodman is a tiny one, we could have, divide the two numbers together and get a closed form simple equation. Now, what is here the story? The story goes like this. When there is no preload, okay? When there is no preload, يعني انفك البولت. خلاص البريلود راح. C will become 1 and Fi will become 0. And what happened? اللي راح يصير بأنه إحنا راح نعوض عن C equals to 1 and Fi equals to 0, and then we get this factor NF0. NF0 is like يا شباب an indicator if there is if you are gonna have a no preload. Now, how is this happen, ya shabab? Why do we need to worry about this? I'm gonna talk about it in a minute. The preload is beneficial for resisting fatigue. So, in order to resist fatigue, we need to put a preload, and NF divided by NF0 should be greater than unity, greater than 1. With Goodman, ya shabab, if we use Goodman, again, because it's a tiny small relation, with Goodman, when NF over NF0 is greater than 1, we can put an upper bound on Fi. What does this mean? It means that our Fi should be less than or equal to 1 minus C multiplied by SUT by 80. Now, this is now another guideline for how much Fi should be based on fatigue. Do you understand? Now, what happens here, ya shabab, is that the reason why we talked about no preload and we put an upper bound or a bound on the Fi is because fatigue, ya shabab, shakes the machine, and vibration, ya shabab, might end up letting the nut get loose. Do you understand? And that's where the problem happens. So you want to have a preload which is gonna secure that the nut will not go loose. وإذا تعرفون يا شباب, when you go to the machine shop for your car maintenance, في مصطلح عام يقولوه هنا السيارة تحتاج تربيط. And what does that mean? It means that there are maybe some rubbers get broken, or some bolts needs to pre-tension again, because you're driving the car and shaking it more and more and more, and the nut may start getting loose because of that vibration. Okay, so as we do before, if we have cyclic loading, we are always afraid that the first cycle will trigger yielding, which is here proof load. So what are we gonna do? We are going to just use our same convention. NP for fatigue is equal to SP, which is the proof strength, divided by the sum of the mean plus the amplitude. Because when we sum the mean and the amplitude, it means that we are looking at this point, the maximum point here. This point is measured all the way down. So when we measure it, we are guaranteeing that when we reach that point, there will be no yielding from the first cycle. Okay. Let's talk about this example. I'm not gonna solve it by hand because 90% of this example, we have done it before. We're gonna talk about it together in the remaining 12 minutes or so, maybe even less. And you will see that now the whole story خلاص خلصت يا شباب. The entire story ended. Finally, from the beginning of the chapter, we were talking about these bolts. How do we make them? What is the length of the thread? What is the knot? What is the head? What is the washer? What? The whole story ends here. This is now, again, the classical problem of a pipe with a flange, and there is a brusher. And now we want to know if the bolts are going to be safe in terms of fatigue or not. Okay. طبعا هذا ما يعني يا شباب انه the previous example that we did with respect to monotonic loading, which is static loading, is not important. It is. But as we told you before, and we keep telling you, fatigue is the problem. Fatigue is responsible of failing 70, people say up to 80% of machinery. And while static loading, ya shabab, you can turn on the power, and then when the pressure goes, and then static failure is a problem, you will see leaking in the minute you turn it on. بس fatigue, no. fatigue يخدعك. يقول لك ما فيني شيء أنا. البيب ما في شيء. كل شيء تمام. And then you look, there is no leakage, وتروح وتنام. سنة سنتين ويجي يوم على غفلة ويفاجئك. You understand? So, what is this? This problem says that in this figure, we have the dimensions A, B, C, D, and E are given to us. So we know all the dimensions. طبعا ركزوا يا شباب. D and E will determine the frustum. Yeah, they are very important right now, and they are different. Okay, the cylinder is made from ASTM 35 cast iron with E equal to 96 gigapascal, and the head of low carbon steel. Okay, so this one is made from cast iron, and this one low carbon steel. Is this a good news, ya shabab? I don't think so. It means you need K1, K2, K3, and so on. So there are 36 M10. So we have 36 bolts. Each one has a 16 millimeter diameter. Okay, with 1.5, this is what, ya shabab? This is the lead. And then ISO, that's now the class of the bolt, which is 10.9 bolt, tightened up to 75% of the proof load. What does this mean? 70% of the proof load, يعني هو قاعد يقول لك it is non-permanent, because 90% is for permanent. During use, the cylinder is pressure fluctuate between 0 and 750 kilopascal. Find the safety guarding against fatigue failure of the bolt using Goodman, Gerber, and Asmi Electric. You understand? Now, first thing first. Yesterday, I think, no, not yesterday, the class before, I talked to you about the effective pressure, because the effective area is not necessarily the same as A. But here in this problem, there are ceiling, we can see them, and in practice, the area is not this, does not have this diameter. It has a little bit bigger diameter, but in the question, we were not told. So if you are not told, you will assume that the area is A. If you were told that the effective diameter for the ceiling or something like that, then you should use that diameter. Okay? Now, so what are we gonna do? Look, we came to the pressure, okay? And then we multiply it by the area, and we divide it by N. الarea يا شباب by D square, right? By D square, لاحظوا, the diameter is 0.9. What is 0.9? It's A. Why A? Why not a little bit bigger? We were not told. If we were told, then it's okay. We will use that. Then we multiply this by the pressure. انتبهوا يا شباب. P capital is the load per bolt. P small is the pressure. Divided by the number of bolt. طبعا هذا by over 4, huh? D square. This is the area. And we get 9.72 kilonewton per bolt. إيش معنى per bolt؟ يعني each bolt with its member is subjected to, this is it, one big combination of bolt and member being subjected to 9.72 kilonewton per bolt. Okay, that's it. Now, what is SP from, look, table 811. SB is 830 megapascal, SUT is 1040, and SY is 940. What is the tensile stress area from table 8.1? We know it. What is the A diameter? The diameter of the bolt is said to be, I said 16, I don't know why. I was confused. It's M10. Ya shabab, I'm very sorry. This is M10, so 10 millimeter, the diameter D. So if this is the case, then I just use the diameter to calculate the area of the unthreaded portion. That's the area. Then the same business. We go find LT, and then we go from the table A31, we find for M10, what is the height of the nut, which is 8.4 millimeter. And then do you remember the length of the bolt? The length of the bolt equals to the length of the grip plus the head. It has to be greater than this. And in reality, ya shabab, I don't know why the solution is, this is from the book, but this one, it should add to it 1.5 multiplied by 2. 1.5 is the lead. And the lead, when you multiply it by 2, you will add the length of 2 threads to the 53.4. So what happened then? We got, yeah, you know, if you do that, ya shabab, you will add a 3. So it will become 56.4. But in the book, it decided that I'm going to choose L60 from table A17, which is the standard table. So I am already adding actually multiple 3-something knots, threads to the bolt. Then we find small LD, small LT, and then we find KB. KB is very, very important. Then, ya shabab, we draw this diagram and we decide that there is one frustum, and then there is another one, and then there is a third one. So you know the business now. You find K1. Look, this is E, T, D, capital D. And then you find K1. This is E, D capital, small t, and D. And then you find K2. This is very nice way of writing, especially in the when you do it for exam or a quiz. It makes it so easy for us and for you to understand. This, and we find K3. Then we add 1 over K1, 1 over K2, 1 over K3, which is equals to 1 over Km. So Km is the reciprocal of all of that. And then we got 1057 meganewton per meter. When we do that, we can now calculate C. خلصنا يا شباب. C, we find C. Then how do we find Fi? It's 0.75 multiplied by AT multiplied by SP. And then we find this load. Then if we do that, we can find the sigma I, which is equal to Fi over AT. لاحظوا يا شباب, this is the ISO 9.6. What is the endurance limit? Is 162 megapascal. So what happened, ya shabab? We can go now to Goodman and find SA. SA need SE, SUT, sigma I, which are all available. And then I go and divide them by the amplitude. The amplitude that I have. What is the amplitude? Why is it not calculated over here, ya shabab? The amplitude is this. It is CP divided by 280. Okay, so that's equals to 20. And there you go. This is the factor of safety. You do the same with Gerber, and then you do the same with Azmi elliptic. Why is that? Yeah, this is it. I think, ya shabab, somehow it is calculated in the wrong way. Yani the presentation here has something coming first. So this is the factor of safety for the Azmi elliptic. This is for Gerber, and this one is here for Goodman. Okay, I'm sorry, ya shabab, I am very late. I need to stop here. Next class, inshallah, we will talk about shear joint, and it's going to be the last thing that we do for the term. Okay. At least for the final exam. Let me now take your attendance. If you don't mind, share your screen. Share your, turn on your webcam. I need to take your attendance in 1 minute, which is very tight. You can leave after I call your name, ya shabab, okay? Faisal?
Yes, present.
Yes. Yusuf Abutaki? Yeah. Hamad?
Yes.
Ali Al-Qahtani?
Yes.
يوسف اليوسف.
Yes, here.
يا ماجد العباد.
Yes, I'm here.
العلي حسين. اوكي محمد. محمد where are you؟ حسين العياش.
يس موجود.
and حسين مبارك الدوسري. مبارك. احمد
موجود يا دكتور هنا.
علي الحاجي زهير معجب.
يس دكتور.
اوكي سلطان الحربي.
يس دكتور.
عبد الله جام. اوكي يو ار هير. سلطان الهوشان. سلطان الهوشان. عبد الرحمن.
يس.
خالد العتيبي. اوكي العوفي.
Yes.
فارس.
يس.
وين فارس؟ فارس القحطاني.
موجود يا دكتور.
اوكي يا ثابت القحطاني. علي رمضان. think I saw him. Yeah. هاشم سادة. هاشم. ماجد.
يس دكتور.
عند محمد.
يس دكتور.
أحمد سلطان.
Yes, doctor.
مشعل يامي.
يس دكتور. يس هير.
وليد.
Yes, دكتور.
وليد. محمد زهير. عبد الله.
Yes.
يعني زهير. أحمد.
Yes.
اوكي that's it يا شباب.
Doctor, I am from the other section, please.
Yes, Doctor, me too.
Okay, just wait a second. I need to go to the other section. Who is it here from the other section?
صالح السلطان دكتور.
صالح السلطان. Okay.
Thank you.
فيصل حامد.
فيصل. فيصل. Okay.
سعد الحزمة دكتور.
سعد.
middle. Yes, sir. Just above the mouse, doctor. Just above the mouse.
Saad, yeah, I see you here. Okay, who else?
Thank you, doctor.
Welcome.